All right, so one of the things that is not showcased in the videos is just this little thing that a little script that I wrote going through because what I wanted to do was write a script that would calculate the valid triangles for movement in VR in real time. So basically what this is doing is saying that if we set a degree threshold on how steep an incline should be, um, and we attach this calculate valid teleportation triangles to an object, it will read that degree threshold, and whatever triangles in your mesh happen to be within that degree threshold will be marked as valid for teleportation. So here we have just a cube, um, and you can see that we've got, triangles going across. It's a little hard to see the cross sections on those colors, but you can see it there. These pink ones are valid, right? Because if we look at it, it's clearly less than a 45-degree angle, and we can kind of play with it, right? So um, as we rotate it around, we can see that these remain valid. What we'll see is when we go past 45 degrees, they are no longer valid. Now we have these. These are our more upward facing triangles in our mesh, right? And these are no longer valid, right? Hey, so here's an example of the calculate valid triangles working on a more complicated object. Um, and that's my daughter in the background. uh, so what you can see, this is kind of a spherical object that we have here. And um, what I'm doing is, as you can see, the pink triangles are the ones that meet our degree threshold. Um, and as we rotate it through, it's constantly recalculating, deciding, okay, what could I possibly, what's a valid triangle, right? Um, so this gives us an alternative as you rotate it around on any of its axes. So it's completely dynamic and not dependent on the shape that you're using. Like it's just totally meshes, right? Or triangles within your mesh. Um, So yeah, just an example of something that I think is cool from a coding perspective that is, not in my other materials so far, and something I thought you'd enjoy seeing.